Okay, so here I have my same rectangle class, right? You can see I've got two constructors, two setters, two getters, an area function, a display function, and then all of my functions that are not written inline are in here, rectangle.cpp. And I have a completely new main program, so I am including rectangle.h. And then when I come into my main program, you'll see here, I just have one rectangle and I'm going to ask the user for the length. So I just declared an integer variable to hold the length and the width that I'm getting from the user. So then I use my setLength function to set the length of rectangle R1 to whatever the user entered and set the width of rectangle R1 with whatever width the user entered. And then I just display the information out using my get functions. So I'm going to run it so you can see over here. I don't know, I'll just put in, I'll put in 2 and 3 for right now. And then it does display the length is 2 and the width is 3. All right, so this is fine, but like if I had a second rectangle or a third rectangle, do I want to repeat all this code for the second one and then repeat all that code for the third one? It seems like it might be much better if we were to have a function instead. So maybe I will create a function to get the rectangle information, and then maybe one to display rectangle information. So let me just take this out and I'm going to put it in a function called get rectangle information. And I'll talk about what I'm going to pass it in a minute. Okay, so in here, I'm going to take my length and width and move those inside the function because that's where I'm going to be using them. All right. What I want to do is, instead of using R1, which is very specific to the main program, I'm just going to give this a generic name like R. Okay. And what I'm going to do is I'm going to pass a rectangle object R to this function. So this rectangle is going to come out here. We'll have the user enter the length, we'll store it, the user enter the width, we'll store it, and then when we return, we want this parameter to have that length and width in it. So this is going to be a reference parameter. Okay, so up here, let me put my prototype in. I'm just going to take this comment out for now. And when I call it, it'll just look like this. But I'm going to put R1 because that's the name of my variable here in the main program. So rectangle R1 will get passed into R, right? They're the same thing. We're just going to call it R, and this function will fill up the length and the width, and we'll come back here. Now, these aren't member functions. We don't have R1 dot in front of them. These are just regular functions that are in our main program. So if I had two more rectangle objects, I can call that function again. Okay, now let me run it. It's going to prompt me. We're only going to display R1 right now, but just so we can see. I'll put 2 and 3, and then I'll put 4 and 5, and I'll put 6 and 7, right? And then here is only displaying the first one. But see, if I'm going to do this a bunch of times, it would be better to have this all in a function, and in this case it would be required to be a reference parameter, so that length and width that we store in the rectangle object get passed back to main. Okay, so now what I'm going to do here, I just might put just to put some space on the screen. I'm going to take this out and I'm going to put that in a function called, I'll call it display rectangle info. Now again, we need to pass it a rectangle, and I'll talk more about the parameter list in a minute. Okay, so again, I'm just using this generic R so I can pass in as many rectangle objects as I want. Now, this would be a value parameter, and we've seen like it when we talk about structures, we talk about arrays, these are larger data structures, and a value parameter is not very efficient because you have to make a copy of a value parameter. So as our data types become data structures, they take more space to make a copy, they take more time to make a copy, and it's not efficient. So we make them reference parameters. That way they share the memory location. They don't make a copy, but when you do that, we know that if anybody changes the object R inside this function, that change is going to go back. So this would be an example of where we want to use a constant reference parameter. So we've seen the use of constant before in our parameter list, and this is just another example. So when we're writing functions that use our class objects, we probably should be either using reference when there's going to be a change to the object, like in the get rectangle info, or constant reference when we're just using it and not changing it. And then here I can just call this with R1, and I'll just copy this so I don't have to keep typing this over again, and R2 and R3. Now remember, the benefit to using classes is that you can reuse your code. So here's a whole different main program. You're still using the rectangle class, but you know, it's just a completely different main program. So I can have as many main programs as I want that happen to utilize our rectangle class once we've written it. All right, so I'm just going to put in 2 and 3 for our first one, 4 and 5, 6 and 7, and 2 and 3, 4 and 5, 6 and 7, and there's the information. And that would be how you can pass class objects to functions just like anything else, right? A rectangle is now data type in our program, so we can pass something of type rectangle out to a function. We could do it as a value parameter, a reference parameter, a constant reference parameter. We've been looking at these types of parameters all semester long, but because it is a larger data structure, you're not going to want to use value parameters because they're inefficient due to the fact that they make a copy, which will waste space and time.